All right, so in the past when we talked about trigonometry, we were really stuck with only looking at right triangles. Well, how often do you get to see right triangles? It's not super often. So wouldn't it be great if there's a way to use trig to find angles and side lengths of triangles that were not right triangles? That's where the law of sines and the law of cosines comes into play. It will allow us to find side lengths and angle measurements of triangles that are any type of triangle, whether it's obtuse, acute, or right. And these laws are super helpful, and they're used all the time in real-world applications. But before we can use real-world applications, we need to actually learn what the law of sines is and what the law of cosines is. Now, the law of sines is definitely the easier of the two to remember. The law of sines simply says that if I have a triangle, and we'll call this triangle side length A, B, and C, which means that this is angle A across from side A. This is angle B from across from side length B, and this is angle C. And notice how capitals have to deal with angles, and lowercase has to do with side lengths. All right, so the law of sines, using this diagram here, is going to say that the sine of angle A over side length B will equal the ratio of sine B over side length B, which is also equal to the sine of C over side length C. Now, obviously, the ratio of sine A over side length A will equal the ratio of sine C over side length C. So I can use this ratio to find any side length or side that I need to find. Obviously, you need 2 out of the 3. So if you have 2 angles and 1 side, or 2 sides and 1 angle, then you can figure everything else out. For the law of cosines is a little bit more complicated, and it's definitely a little bit harder to remember. So here we go. And there are three different laws of cosines. Notice how you have 3 different ratios here, but it does really sort of look like one equation. The law of cosines will have 3 separate equations. We will have the side length A squared is equal to the side length B squared plus the side length C squared minus, and here's where it gets a little bit complicated. We have 2 times the side length B times the side length C times the cosine of A. Now, the way I like to remember this, and the way I remembered it when I was learning it, the missing side length will go with the angle measurement in the cosine, and the B and C will show up in the other pieces. So using that framework, that would also mean that side length B squared is equal to A squared plus C squared minus 2AC times the cosine of B. Well, that would also mean that the side length C squared is equal to A squared plus B squared minus 2AB times the cosine of C. And they all follow that rule where the missing side length is going to go with the cosine of the same letter. And so those are the laws of sines and law of cosines. Simple enough. Let's start applying it. We'll probably need a little extra space here, but that's okay. So we have triangle FGH, and we're trying to find the lengths and the angle measurements. And so here we go. Well, I have this angle of 39, and it is opposite this angle here? Well, that means I can find FG, because the law of sine says that the sine of 39 over this side length is going to equal the sine of 32 over side length FG. And I'm going to call this side length K because I haven't said K enough today. So that would be over K. So doing a little bit of mathematics, I would end up with multiplying both sides by K. So I would get K times the sine of 39 over 40 is equal to the sine 32. So I'm going to multiply by the reciprocal, and I'll get K is equal to 40 times the sine of 32 divided by the sine, and that's a backwards. Yes.
Students and teachers, please excuse the interruption.
No.
Due to the ice and snow and freezing temperatures, we will have an inside day today. Inside day. Thanks.
I bet you can hear Yemma screaming from her classroom. No. Anyways, okay. So let's go ahead and do this. So and you're gonna have to listen to me, which is not nearly as exciting, unless of course you're Meg and you're listening to me at 3 times the speed, in which case I sound like a chipmunk, which is always exciting. So we have the sine of 32 times 40, and that gives me 21.19677. I'm going to divide that by the sine of 39, and so I get a side length of 32.68. Sorry, 33.68. All right, next one, same basic idea. I have 2 side lengths and an angle. I have that angle that is opposite a side length, so I can again use the law of sines, because I'm looking for angle Q, which is opposite the side length of 6. So the sine of 51 over 8 has to equal the sine of Q over 6. Math magics, here we go. So I multiply both sides by 6. So I get, and 6 divided by 6 and 8 share a factor of 2. So I will get 2/3 the sine of 51. And that's equal to the sine of Q. It's an ugly Q there. That's much better. So the sine of 51 is 0.777. I'm going to multiply it by 2/3, which gives me 0.518. And then I'll also write this down in case I make a mistake entering in my calculator. And that's equal to the sine of Q. I should have used a big Q. And so now I do the sine to the negative first power button. And that gives me that Q is equal to 31.2. All right, let's take a look at this problem. All right, so now we do not have an angle that is opposite a known side length. This is the time for the law of cosines. So I'm trying to find this. I'm going to call this A. So that means that A squared is going to be equal to 35 squared plus 30 squared minus 2 times 35 times 30 times the cosine of 110. And so this is actually a pretty straightforward problem. 35 squared is 1,225 plus 900 minus, well, 2 times 30 is 60. 60 times 35 is 2,100. And the cosine of 110 is negative 0.342. All right, so then I multiply the cosine times 2,100. So I get negative times a negative is a positive. So we get 718.24. And we still have the 900, so I'm going to add 900. I'm going to add 1,225. Oh, shoot. I didn't type that in right. Let's try that again. So we have 718.24. That's why I always write stuff down. Plus 900 plus 1,225. And so I get a squared is equal to 2,843.24. Take the square root, and I get a is equal to 53.32. All right. Our last example, we have a missing angle. Of course we have a missing angle. So, and that angle is opposite, but I don't have any other angles, so I can't use the law of sines. I'm really stuck with the law of cosines. So I know that 7 squared is equal to 13 squared plus 11 squared minus 2 times 13 times 11 times the cosine of t. All right, so we have 49 is equal to 169 plus 121 minus, so that's 143 times 2, so that is 286 times the cosine of t. All right. So let's add those two things together. So 169, I'm sorry, plus 121 is 290 minus 286 times the cosine of t is equal to 49. So I'll subtract both sides, 190 from both sides. And so I'll get negative 241 is equal to negative 286 times the cosine of t. So I'm going to divide both sides by negative 286. So I get positive 0.843 is equal to the cosine of t. So now I do the inverse of the cosine. And I get and when I did that, I got that t is equal to 32.2. Now, the answer key has 33. Why is that? I'll tell you why that is. The reason being I rounded when I plug this in. So it is important to try to keep as many significant decimal places as possible while you're doing these problems. So the actual answer should be 32.578, which would get rounded to 33. And my chopping off decimal places early led to an incorrect answer. That's the way it goes. Okay. I hope you enjoyed your introduction into the law of sines and cosines. Let me know if you need any help. I'd love to help you.